Hello, in this video we are going to go over how to write numbers instead of binary. And first off, we're going to start with the number 38. So binary uses a base of 2, and the form of it is whatever the number is equal to is 2 times some number, in this case q for quotient, plus r, a remainder term. And since we're in binary, r is going to be either 1 or 0. So, for example, with 38, we could express 38 as 2 times 19. 19 in this case will be our q, plus a remainder of 0. Then for 19, that is 2 times 9 plus 1. For 9, this would be 2 times 4 plus 1. 4 is 2 times 2 plus 1. 2 times 2 plus 0. 2 is 2 times 1 plus 0. And then finally, we are doing 1 is equal to 2 times 0 plus 1. So now the way that this is written in binary, this goes from the bottom up to the top. So 38 is a number using base 10. This is equal to, instead of binary, 1 0 0 1 1 0. And you might be wondering, how can we check to make sure that this is actually correct? The way that this number here is written in binary, and I'll write this up here so I could reference it. For binary, these numbers take the form of... Let me just write these very quickly before I state them. So that's a 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, so on and so forth. So this 0 corresponds to the 2 to the 0th power. This 1 is 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth. So this looks like 1 times 2 to the fifth plus 0 times 2 to the fourth plus 0 times 2 cubed plus 1 times 2 squared plus 1 times 2 to the first plus 0 times 2 to the 0th power. So 2 to the 5th, this is 32. These are just zeros, we don't care about those. 2 to the 4th, that'll be 4, and then 2 to the 1st, just be 2. And if we add 32, 4, and 2, sure enough, we get the number 38 back. Now, using the number 49, 49 can be expressed as 2 times 24 plus 1. 24 would be 2 times 12 plus 0. 12 is 2 times 6 plus 0. 6 is 2 times 3 plus 0. 3 is 2 times 1 plus 1. And then finally 1 is 2 times 0 plus 1. Again, from bottom to top, number 49, which is again base 10 number, is equal to, in binary, 1 1 0 0 0 1. And again, if we want to check our work with that, This corresponds to 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth. So we are doing 2 to the fifth, 2 to the fourth, all zeros all the way down to 2 to the 0. So again, 2 to the fifth, this will be 32, this is 16, and 1. We add all those together, we do get the number 49 back. So that's an example of using binary to write numbers. And certainly hexadecimal numbers are the same exact concept. We would though be using a base of 16, which means the remainders can be any number between 0 and 15. But that's the general idea, though, of how to do that. Thank you.